Good morning. How you guys feeling this morning? All right, well, my colleagues and I are excited to welcome you to our breakout session, first session of the day, experimenting at the frontiers with Azure AI Foundry Labs. My name is Ashley Llorens. I'm a corporate vice president in Microsoft Research. And so I'm going to kick us off actually with a view from research. As you've experienced Build this week, the keynotes, the breakout sessions, so much of what you're seeing has its origins in research and in science. And more broadly, the foundations of AI, of course, are springing from research and science. And from my seat in research, what I can tell you is that the breadth and depth of what we're seeing now in terms of the pace of advancements is really incredible. Even in research, we have a challenge on our hands, just kind of keeping up with ourselves and pacing ourselves. And as we've interacted with the developer community, we hear the signal from you that there's more we can do to help you keep up with what's the advancements and what's coming next, and help you to learn by doing and experiment. And so that's really the motivation behind this thing we'll be talking about in this session, Azure AI Foundry Labs. And so what Labs is for you is going to be your curated feed from the research community. And by curated, I mean the things that we think will be most relevant to the developer community, things that you can learn about, see, and also begin to experiment with. And it's worth taking a step back just to kind of think about and reflect on the moment we're in. I've had the great privilege of working in AI and machine learning for my entire career. That's pushing 20 years now. And I can tell you, we're talking so much about agents now. It's a little bit surreal because agents has always been the dream. Automating physical tasks, cognitive tasks with powerful agents. And for me, personally, what I had the opportunity to work on was autonomous underwater vehicles. So I spent actually years of my career at sea trying to make smart autonomous systems or agents that could operate underwater. And so where we were using machine learning back then was to help those underwater agents perceive their environment using sonar and signal processing and machine learning, and then make autonomous decisions about how to pursue their mission. But what we never had in those experiments was anything resembling reasoning, human-like reasoning. So that's what multimodal foundation models are giving us today, is the ability to have something like human-like reasoning, having these agents be able to reason under uncertainty, and then powering agents with that reasoning. And so the pace is just continuing to accelerate. The advancements are very exciting. And what we'd like to do, and what we'd like to help you do, is see beyond the headlines. What's coming next? What does it mean for you? What does it mean for me? But this actually is not a new aim at Microsoft. In fact, the aim to have part of the company really helping the rest of the company and society see beyond the headlights goes all the way back to a memo written in the early 90s by Bill Gates and our then CTO, Nathan Myhrvold. And in this memo, they did call for the creation of a research group or team at the company that would do exactly this, help the company see beyond the headlights, but do that in a way that was more deeply integrated with the rest of the research community, the academic research community around the world, and then partnering deeply with the product teams and business partners in the company to translate those new ideas into real-world impact at Microsoft scale. So since that point, the thing we call Microsoft Research actually started out as a small team in Redmond, and it's grown. It's grown a bit. It's now a global ecosystem of labs and locations around the world. And in these locations, we've got a big cross-section of the best and brightest. Everything from core computer science to socio-technical research and design. But when you look at these boxes on this map, don't just think about the locations, and the folks that are in those locations. In each case, these research communities are embedded in their local societal context. They partner with community-based organizations. They partner with their regional academics and academic partners and institutions. And inside the company, the folks in Microsoft Research connect to a very vibrant ecosystem of applied researchers and applied scientists working to translate those ideas into real-world impact through the products that Microsoft puts out that you've heard so much about this week. So it's really, truly a global research ecosystem. And what's unique about the part of that ecosystem we call Microsoft Research is the empowered culture. So we have the accountability in Microsoft Research to actually pick which risks to take on behalf of the company. What's the most important work we can do? And I'm showing an illustration now of that culture in action. So you heard in Satya's keynote about a model series, a series of small language models called Phi. Okay, that series actually started out as a small research project in Microsoft Research. A few researchers, just a few years ago, were really intent on understanding how much intelligence they could fit in a small package. And that was a pretty contrarian view at that time. At that moment, so much of the industry was focused on all things scale, more parameters, more data. And the insight of this team was that to create similar reasoning powers in a smaller package would require a focus on quantity over quality of data, more carefully curated data, and new ways of using large models like the GPT series to actually create training data for smaller models. In fact, one of the researchers got the idea for this reading bedtime stories to his daughter, and they began to use the GPT series to create textbook-like training data. All right, and so on the keynote stage at Ignite just a few years ago, Satya announced the first product coming from this research project. We called that Phi 2. And this Monday, you heard Satya now talking about the fourth generation of this model series, which is really making strides at the frontier, that Pareto frontier between intelligence and trade-offs like cost. In fact, you can't go and buy a Copilot PC nowadays without getting your own local copy of Phi, a copy of Phi called Silica that's been optimized to run on the Copilot PC device and powers many of the AI features. In fact, we've got many customers using this series now. You heard in the keynote about Air Japan, Japan Airlines using this to create reports when they're not necessarily connected to the internet at altitude. And the innovation continues, actually. The folks in research, working together very closely with the folks on our product side, have just released Phi 4 reasoning, which you can find in Foundry and Foundry Labs. So this is a great example of that culture in action and how quickly everything's moving. And that's just one example. The folks in this global ecosystem that I've talked about are really working across all of the important frontiers in AI, including advancing foundations like small language models and frontiers of multimodal reasoning, multi-agent platforms, which my colleague Ece Kamar will talk about, and even efficiency. How do we continue to improve the efficiency to drive the cost down? An area that I'm personally extremely excited about is the application of multimodal generative AI to scientific discovery and teaching models to learn the language of nature, the language of physics, biology, chemistry, to accelerate discovery across the sciences. And you heard Monday in the keynote that actually Microsoft has just announced a new platform, the Microsoft Discovery Platform, which will benefit from a lot of this. You can see in healthcare, for example, models that can start to speak the language of medical imaging to do things like the multi-agent tumor board that we've put together with our partners at Stanford. So accelerating discovery across the sciences. And finally, really ensuring that we are true to our mission to empower everyone and making sure that these advancements in AI empower people around the world, no matter what societal context they happen to be in, no matter what language they happen to speak, even if that's a low-resource language, or no matter what their physical and cognitive abilities happen to be. And so with our labs, for example, in India and Africa, we are looking at AI, pushing the bounds of AI for low-resource languages, and really just broadly advising how the company's moving forward in responsible AI. So just pausing to reflect. That's a lot. That's a lot. And so again, what we're doing is introducing Azure AI Foundry Labs, which would be your curated feed for the innovations coming out of this community, really with the developer community in mind. And I'd like to invite my colleague Vaidya to come up now and tell you a little bit more about what we're offering in labs today.
Thank you, Ashley. Hey, folks. How are you doing?
Good.
How's it going on? Hey, I'm Vaidyaraman Sambasivam. I'm partner head of product of Azure AI ecosystems. As Ashley said in the start, we believe the pace of AI innovation is not just moving fast, it is moving exponentially. Show of hands, how many in the room feel that way? There's no doubt about that, yeah. I think the cadence and velocity of this innovation is shifting so drastically. In fact, just to give an analogy, what we have moved away from a model shipping every month to now innovations happening every few days. So the landscape is changing dynamically in this area. So what do we do now? At the end of the day, we got to, am I even not moving the slides? Sorry, folks. That's why we have the Foundry Labs. Basically, as Ashley said, like how do we now use this as curation for these. Let me get started with the video. You know what, folks? I actually intentionally fumbled at the start. Just to wake us all up. You know, I am actually truly inspired and motivated. Did I do a good job acting as if I fumbled? Because honestly, I'm actually inspired to be here, folks. This is a time to be. This is the place for innovation. I was looking at my team there. They was looking at me and they was like, oh, why they are fumbling? Is he really fumbling? Honestly, I mean, this is a stage where innovations are happening so dynamically. I used to own the models team in AI platform. We used to ship this. We used to be in the MLOps era where the transition needs to happen from data scientists to taking the models to production, right? It was about launching models then. Now, the pace is so fast that the innovation is happening so fast that really you got to be on the bleeding edge to start finding a way to discover these models, discover the agents that Ashley is talking about. And we launched Foundry Labs last year. Think of it as a front door for all the latest and greatest innovation from Microsoft research teams. And when I say research teams, this is not just, there are multiple teams in Microsoft. There is health research and so on and so forth. So it's kind of this having access to early stage research, I would say, which is going to otherwise be sitting in a GitHub repo or in some random open source ecosystem, right? So how do you now get access to these in a very curated way? We have this website where you could just go try out these different models and get inspired by it. You can learn, you can explore, right? And just to give an example, irrespective of what domain you come from, right? Let's say you're a game developer. How many game developers we have in this room? Anyone? There you go. That's great. We got this Muse model, which is a human interaction with the world. It's good for game simulation. You can try that. It's good at it's called the VAM model, right? Somal, it's basically the world and human action model. Or if you are looking at biomedical domain, anyone who's interested in biomedical domain here? Oh, there you go. I got a few hands there. We've recently released this EvoDiff model, which basically is good at protein structure. It generates a lot of protein structures, and it is good at ominate. It creates thousands of protein structures per second. So it's like, these are great innovations that you could look at and get inspired from. But then the question from the room might be, what do I do next? How do I take this? How do I prototype? How do I integrate into my own chatbot or agentic workflow or app? That's where you got the AI Foundry. We have got a lot of breakout sessions in AI Foundry. How many of you have attended the AI Foundry sessions here? Oh, see, we've got more than 10 sessions there. So I'm not going to dig more deep into this, but the main point here is we've got these collections in AI Foundry. So you could go use this, deploy these models out of the box. And what we have now is a subset of models. As you see in the screen, we've got a subset of models from the Foundry Lab. We could basically use that. And we want to learn from you. We want to hear your feedback. And based on your feedback, we'll start adding more models to these collections. So please give your feedback to us. All right. So that's it. I mean, get inspired from Foundry Labs. Prototype through AI Foundry. And we have got Shannon from our research team to now show us how we could do some prototype with all this MCP server, which is a buzzword now, and Foundry Lab collection. Thank you, folks.
Thanks, Vaidya. All right, thank you, Vaidya. So I am Shannon Monroe. I work as a creative technologist in the Microsoft research team. And I will tell you that we live for the stuff that comes out of research. We cannot wait to get our hands on all the good stuff that the teams are creating. We love to add our own mix into it. But the thing that we realized was, well, as an example of good stuff, let's talk about 𝗦𝗽𝗲𝗸𝗀 v2 here. This came out of one of our teams. This uses computer vision to turn an LLM into a computer using agent. We can parse a screen, we can tag the inputs or the different elements of the screen, and we can interact with them. So all of a sudden, I can read OS agents, I can create web agents, I can do all of these super powerful things, and it's crazy fast. Like, the problem that we had as a team was when we started talking about what we wanted to do with 𝗦𝗽𝗲𝗸𝗀, there was about a 5-day cycle that it was going to take us to adopt it. We were going to have to talk to the team, we were going to have to read the research, we're going to have to bring the repo down, we're going to have to start working with it. We had a conversation, why wouldn't I put an agent in that? Why wouldn't I change that build section to an agent conversation? So we started really simply. We built an MCP server, and we stuffed it, the Model Context Protocol, we stuffed it full of research and said, here's the repo, here's the documentation from the team, here's the things we know about this model. Help us have a conversation about it. We thought this would be great. This expanded a little bit after we started playing with it, though, where we realized that we could take the Foundry Labs hosted models, and we could provide the integration instructions as well to the agent. And all of a sudden, it was able to do real coding. So we started wanting to have conversations just like this, which models are available to us, talk to us about the catalog selection, talk to us about our vision for what we wanted to make, tell us which models we should go look at, what more research we should go do. What we discovered was that we could build the prototype. And rather than taking 5 days to adopt the model, we were at 30 minutes. It became faster to automate the task than to perform the task. So this particular prototype that you're looking at here with 𝗦𝗽𝗲𝗀𝗀𝗀, we're building a cognitive load analyzer. We can upload a screenshot to it, and it'll come back, use 𝗦𝗽𝗲𝗀𝗀𝗀𝗀, and tell us where the difficult parts of the interface are. It got even better. As the team got more used to coding in this way, we went from 30-minute conversations with it to adopt a new model to 10-minute. And I actually have a demo here where I can show you the latest version of this and show you how sophisticated some of these outputs are getting. So this is what our prototype looks like now. We actually generate this full heat map to tell us where designers should spend more time, where we might want to move some of the elements apart. We even integrated with 5.4 so that we get back a report that tells us what changes we might want to make. And this is Japan Airlines website, which you can see is pretty effective as an interface. Just for fun, let's see if we can upload archive. We'll tell it to analyze. And once we started doing this, it became really impossible for us to stop. Like, we could not stop building more prototypes with the team. You can see here where there's a density of information that is going to be difficult for your users. It's going to be a challenge for people to work with. And then actually, let me show you one more thing before I go away from this. So all of this work we did, we thought, this is great. We can analyze UX on screens and understand it, because that's what the computer vision model was trained on. But because it was so cheap and so fast and so easy to integrate with, we could start to have other experiments. And we started getting really goofy and showing it pictures of airplane cockpits. And it came back with an analysis of where the cognitive load might be in this interface. So think about that. You might be able to, we showed it car dashboards, other things. It comes back and tells you all these great moments that you're like, wow, that could be designed better. All because of the fact that it was so easy to build and integrate with. So this is an example of Magentic 1. This is another piece of research that AJ is going to show you in a few minutes. This actually builds a group of agents that go out and do a task. So here we're asking it to read the National Parks website and help us build a hiking itinerary. But all of this is live. As soon as the agents research and find out that a park is closed or there's been some bad weather, this whole thing is able to update and work in real life. All right, so this is fun, right? We all love demos. I would like you to go to that AKA MS Foundry Labs, and you'll find an article there, and we'll give you the link. But it's really this easy. You can start working with Microsoft Research immediately. Clone our repo, use the template. I'm sure everybody in this room has cloned a repo before, right? I don't have to go through all these steps. We love to use it in a code space. Obviously, that takes a few minutes to set up. Once you have it running, go into GitHub Copilot, switch over to agent mode, and then you can choose your favorite model. We're big fans of 4.1. 3.7 works really well as well. And then hit refresh, just to make sure that that MCP server is included. And you'll be able to see how the MCP server works. We're giving you all of the code. You can actually inspect and modify it in any way you want. We're going to keep populating it with more research that's coming out of the team so you can do stuff. And this is the prompt that we like to test with. This helps us build a prototype comparator model. So you can basically go in and choose different models and compare how a single prompt might act under each of the different models. When we build, and don't worry, that's in the repo. When we build, our personal record is 3 minutes and 44 seconds to go from that prompt to a working prototype. It's literally now how fast can you think of a new idea? How quickly can that agent go find you a repo that works with that? Can you prove some research out that is useful? So if we jump over to the laptop, I can show you the output of that prompt. This is the comparison app that it built for me this morning. I can choose which models I want to compare. I'm a big fan of hitting 4.0 against 5.4. We can give it a prompt, and we can even choose which model we want to use for evaluating this prompt. So here, I've given it a joke. Let's try something new, once upon a time. And behind the scenes, this is going out, hitting Foundry Labs to get me a copy of 5.4 and test the model. It's going against the 4.1 integration as well. And I should see what this prompt would have returned against all of those models in a moment. Demo gods be with us. Of course, we're calling a lot of models, so this can take a little bit of time. We're totally not going to get it to work. All right. Anyways, if you build we've gotten to a moment that the prompt is more important than the code. So this morning, Ashley was asking me if I could share somebody was asking if we could share the code for one of these prototypes. Yes, look at that. There it is. Great. So you can see here how long the response from 4.0 mini is. You can see how long the response from 5.4 is. You can see that those are pretty comparable. And you can even see that 4.1 gave us a very short response. And we have the evaluations here and scoring as well. So this gives us the ability to evaluate new models that come online really fast and to be able to build this. And since you can designate that prompt, it can be your evaluation app for your problem rather than the one that we've built for you. So I want you to start to think about that prompt being more important than the code. I'm not going to hand you the code anymore. I'm going to show you how we built it so you can build your own version of it. All right. I think that's all I have. With that, I'd like to hand it over to AJ and let her show you some of Magentic 1.
Thank you, Shannon. You make our work really shine with your demos. Hi, everybody. My name is Ece Kamar. I'm a distinguished scientist at Microsoft Research and the managing director of the AI Frontiers Lab. And just like Ashley, I have been an AI researcher for the last 20 years. And from the very beginning, my dream has been building AI agents that can work with people, that can help them with whatever they need. And we waited a long time to get to this point, but right now, we have the basic ingredients to turn that dream into a reality. And we have been innovating step by step to get there. So I'm very excited today, standing in front of you, showing some of the latest work that we have been doing. One of the benefits of being an AI researcher at Microsoft Research is we get to be at the frontier of AI technologies. My lab made an early bet to AI agents 2 years ago. We started working on AI agents. And 2 years later, when I'm at Build this year, it's all about AI agents. It's so exciting. As some of our earlier work is making its way into the Foundry and the Agentic platform at Microsoft, we also get to think about where this technology goes next. So I want to really talk from the kitchen to you about what is really emerging in the agentic space. So the frontier I would like to talk to you is a notion that we have been calling society of agents. Shannon showed these individual agents that have specific capabilities, like the MCP agent or the GitHub Copilot agent. These agents know how to do really, really specific things. That has been a pattern that we are seeing across the industry. But we don't think the future is going to be these individual agents doing things alone. We are imagining a future where these agents that know how to do specific things are going to start to talk to each other. But it's not going to stop there. These agents will start collaborating with each other and with the people to create a completely new network of intelligence. That's what we are calling the society of agents. And we predict that this future is going to enable new ecosystems, new models, agents, humans coming together to discover new things, and also possibly new marketplaces. We really don't know what that's going to look like, but we are looking at that from a research perspective. And we think this is going to really shape how, as people, we do our work. And Shannon showed really great examples of how, as developers, our work, the nature of our work is changing. So we are very much at the beginning of it. At Microsoft Research, we have been designing and building a new computing stack to enable this future of society of agents. Let's look at what the different levels of the stack look like. At the bottom of the stack, we have the agent platform that is designed to be multi-agent, so that these agents can communicate with each other and share information. But we also have a layer on top of this platform level where we are actually investing in agentic teams that can generalize across domains to get tasks done reliably. And our work on Magentic 1 is an example of a such team, and I'm going to be telling you about that. But at the end of the day, our mission at Microsoft is all about empowering our users. We are not aspiring a world where agents are autonomously going to do things. We are looking for a world where agents are going to be empowering people. That's why we are also building a layer on top of Magentic 1 to really create this effective collaboration and interaction between agent teams and our users. That's the work we are doing with Magentic UI. So now I'm going to get into each of these layers and show you how these layers compose together to get more done. So let's start with our platform layer called AutoGen. Has anybody here heard about AutoGen? Yeah, there are quite a few. That's good. So AutoGen is a library we created around 18 months ago from research to enable multi-agent collaboration. And this happened because many of us were very early into GPT-4 in the company, even before there was a ChatGPT in the world. And we were trying to build compelling applications from GPT-4. And of course, GPT-4 is an amazing model. It was so ahead of its time. And still, when we tried to create things that were reliable and safe and controllable, we were running into barriers. That's why we created AutoGen, to create this programming paradigm that instead of just prompting models and expecting things to work, we could actually decompose complex problems into smaller pieces and then create these agents that are specialized at carrying out different capabilities by prompting them in careful ways, and use the agentic chat to bring these pieces together and compose the work to get to the final result. So we were actually really surprised by the reaction AutoGen got. We released the first version of AutoGen, again, 18 months ago, and it quickly became one of the most popular agentic libraries in the industry. And through this, we got to collaborate with the open source ecosystem, internal and external teams, and also grow and evolve AutoGen based on the agentic patterns. While AutoGen started as this compose-decompose programming paradigm, now we actually redesigned AutoGen to be compatible with the future of society of agents, where AutoGen now powers these agentic teams to talk to each other and share information to get more done. We released a new version of AutoGen around 6 months ago. Its popularity has been growing since then. But what is most exciting for me is that now AutoGen is becoming part of the agentic stack at Microsoft. Not only that it's going to be an open source platform, it's now part of the Microsoft stack. But what has been most interesting about the AutoGen experience for us is that we got to work with so many different partners to see where the agentic field is going next. So now, 2 years later, almost 2 years later, it is clear that the future is multi-agent. And with communication protocols like MCP and A2A, there is some protocol layer that is coming in to really direct what the communication is going to look like. And now the agentic platforms are becoming multi-agent. That is great. But we know from a research perspective that just because agents can talk to each other does not mean that they can effectively work together. Communication is not the same thing as collaboration. That is why the problems we are focusing on from a research side right now is building this fabric of collaboration that can push communication to effective work. So one example of the work we are doing in this space is the Magentic One work. So I want to tell you a little bit about that. We all know that what makes a team great is its members. You cannot just throw like random people into a team and expect good work to come. That has a parallel to the agentic work. What the world we are imagining is that instead of creating agents and agentic teams for every single task that you want to do, you can craft together an agentic team to become a generalized power to capture a domain, to really conquer a domain. That's what we have proven, that it is doable to do that with the Magentic One work. So to study this problem, we focused on the domain of general tasks that can be done on a computer. And we developed 2 insights to make this generalist team to happen. The first insight is that for a given domain, you need to carefully analyze what are the capabilities needed in that domain, and create agents that can capture those capabilities really well. So for the domain of computer use, these agents turn out to be an agent that can run code, that can write code, an agent that can execute the code, an agent that can browse files and edit files, an agent that can browse the web really effectively, and finally, an orchestrator agent to become the brain of this team and coordinate the interaction between the other agents. So it is very important to think hard about what are the agents needed in a team, in a given domain. And we came up with a second insight. These agent teams will need an explicit mechanism to keep track of the task progress, identify failures when they are happening, and go back to the drawing board and come up with a plan when needed. So we call this explicit mechanism a task ledger. And when we put these two pieces together, we were able to create the Magentic one. It's available on open source. It's available in Foundry Labs. And this agent team can do various tasks from navigating websites to completing forms and so forth. And when we actually created this team became the #1 team on many of the Agentic leaderboards. So now let's see Magentic 1 team in action for the task of analyzing stock data. What you are going to be seeing here is that once the task comes to the orchestrator is going to initialize the task ledger and start calling in agents one by one and delivering tasks to them, and then compiling the information together. So the user proxy delivers a task to the orchestrator makes a plan, initialize the task ledger, give the first task to the coder agent to write a script for downloading the data. The executor downloads the data, starts analyzing it. And at every step on the way, the orchestrator updates the task ledger. And once the task is identified as complete, the task result is delivered to the user and waits for further instructions. So what Magentic 1 shows us is that creating these specialized agents and make them a part of a team is one way to really do generalist tasks on different domains. So there is a strong idea here about specialization and composing the specialization together. But this notion has a parallel to the way we are building models. Once we know that we are able to create specialized agents, we can now start specializing models to power those agents in very efficient ways. So the 𝗦𝗽𝗲𝗸𝗀𝗀 model that Shannon showed earlier, again coming from my lab, is an example of a really small model, 100 million parameters, particularly specialized for powering the web server agent here, so that the web server can run things really, really fast. And I believe this is going to be a trend that we are going to be seeing more and more going into the future. So the Magentic 1 work shows us that we can start creating these generalist teams, and that's really great. But as I said earlier, our goal at Microsoft is all about user empowerment. And to get to that point, we need to invest in this interaction layer, and that's the work we have been doing with Magentic UI. So why does this interaction layer really matter? First of all, our goal is collaboration between agents and people in delivering value to the users. And second, even with the latest technologies and with the best of class models, the reliability you can get from AI agents today is not where we need them to be. But by creating this collaboration between agentic teams and people, we are really able to bump up the performance of the agentic teams. But there is actually an even more important third point. Now that these agents are able to carry out tasks really openly and effectively on the internet, on computers, we don't yet clearly understand everything that can go wrong. There are serious safety and security considerations around the execution of agents in our personal spaces, in our computers, on our networks. And it is very important that until we get to that level of reliability, we have careful human oversight built into the way we are building agentic systems. That's why we are investing in the work on Magentic UI. So at Build this year, actually, we released Magentic UI just Monday. And Magentic UI is a general computer use agent that is powered by AutoGen and Magentic 1. And we created Magentic UI to study the key problems around interaction between computer agents and people, and also really study the considerations around AI safety and security and human accountability. So one of the design decisions that are embedded into Magentic UI is that all of the actions carried out by agents are actually happening inside Dockers and containers, so that we can really minimize the possible risk of agents doing something wrong in our computers. So now I'm going to show you some of the interaction patterns that are built into Magentic UI. Again, Magentic UI is a human-centered computer agent to do general tasks on the web. You can use it for booking an appointment, to getting some travel advice from the internet. It's really general. When you try it, you are going to see that you can do many different things like ordering pizza from a restaurant. One of the interaction patterns built into Magentic UI is a concept we are calling co-planning. Before the agent executes anything, it shows its plan to the user. The user can revise and edit the plan, and the agent starts executing only when the user approves the plan. The other thing we have built into Magentic UI is multiple transparency layers, and the user can take the control of the agentic work anytime, stop it, revise it, take actions. And even most importantly, we have developed the action guards and safety nets around Magentic UI. We have filters for detecting when the agent may take an action that can be risky or irreversible, like ordering something from the internet. And when the agent detects that it's going to be taking a risky action, before executing, it explicitly asks for user approval and remembers these decisions for the next time it's going to be doing the same task. So AutoGen, Magentic One, OmniParser, and Magentic UI are all available in Foundry Labs. And I'm excited what you're going to be doing with all of these tools and the emerging agentic stack. So with that, I'll pass it back to Ashley.
All right. Thanks, AJ. One more time for our speakers. All right, so for the next few minutes, maybe I'll play talk show host. And so with that, maybe I'll go ahead and invite Shannon and Vaidya back up. And we'll go in kind of reverse order. I'm going to ask you each a question, kind of expanding on what you talked about. And then we'll open it up for some questions and interactions with you folks. All right, so AJ, you told us about the frontiers that you and your team are exploring and kind of multi-agent platforms, the next generation multi-agent platforms, and human user interaction in that context. So what I really want to know is how far away do you think we are from, kind of penetration of those ideas into things people can use every day? And then this is the developer community. So what help do you need from this community in maturing what you showed us?
Yeah, that's a great question, Ashley. So as you and I discussed in our segments, AI agents are not new. But we have some fundamental technologies right now enabling really the reality of these agents. I think there are a number of dimensions that really matter as we are analyzing the progress in AI agents. One of the dimensions is how constrained the agent behavior is versus how generalized it is. And the other dimension is in terms of the actions that these agents have access to. Are they kind of happening in our computers by clicking on things, or they are going to the real world and really capturing the real world? And are we thinking about agents that are doing individual things, or are we expanding to these networks and real collaboration? So these are all dimensions that will be expanding agentic work into the future. For the beginning point of having narrow agents that can do things on computers that are kind of working alone, it is really amazing to say that we are there. When we look into the work that is happening in coding domains, what Satya showed at his keynote in terms of programming agents being able to take his backlog and being able to execute on it, it really shows us that for that narrow domain that's happening in computers, AI agents are there. And I think we are going to be seeing a very strong progression across the dimensions I described so that these agents are going to become more general, more capable. They are going to start connecting to a network and be able to do a lot more true collaboration. What we need help with is basically doing what we did with AutoGen time and time again. What really helped us by releasing, for example, AutoGen was working with the developer community, seeing what you do, what you build, what your gaps are, what are the problems you run into when you work with the stack, and give that feedback to us so that we can keep innovating.
All right. Thanks, AJ. OK, so for the remaining speakers, and I'll add myself to this, I'm going to ask you a different kind of a question. Vaidya, you showed, you gave a glimpse of the model catalog, the catalog of tools and models that are in Foundry. And we haven't had time yet to talk about all of them. And so I'll ask each of us to highlight one additional thing from the catalog that we haven't talked about, but that you want to highlight for our friends here. So let's start with Shannon.
Sure. So, Ashley, this question is terrible. It's like kid in candy store problem. I think for me, the one that I can't get enough of right now is Aurora. I am super excited about the atmospheric predictions that it can make. As a bit of a weather nerd, airplane pilot, and obsessed with RF radio propagation and wireless networks. One of the things that we do in RF propagation calculation is effectively at some point we just declare it's a standard atmosphere. We throw our hands up and say we have no idea how humidity and temperature are affecting the network. I think with Aurora we can start to play with that, and by putting it into the Foundry labs, I've gotten access to it. I can start playing with it in the background, and I can start putting some of these other data sets into it and seeing what kind of results I get from it. And so far, it's been pretty promising. So for me, that's where I'm focusing a lot of my attention.
Thanks, Shannon. That's great. And just for your knowledge, Aurora is a foundation model of the Earth's atmosphere. And so it's a foundation model that's been trained. Add some uncertainty, some error bars to this number, but with something like 1 million hours of training data, measured weather and climate data. And so it can be, it can do things like forecasting, and it can also be fine-tuned to do things like extreme weather prediction, and we've seen some really interesting results from that. And the fun fact about Aurora is actually that it was just published today. It was just published today in Nature. And so you can, for my deep readers out there, you can go out and get real deep into the science in the Nature article that was just published today, but you can also go to Foundry and start playing with it in some of the ways that Shannon mentioned. Okay, Vaidya, what would you call out?
Yeah, I'll actually throw a different perspective here. I mean, just going with by the theme that the innovation is happening rapidly, I believe there is an opportunity, we have a responsibility to give you the latest and greatest innovation. So I'll ask the audience, have you folks looked at Foundry Labs, what innovations you would like to see there? Please give us your feedback. Whatever I showed there in the Foundry catalog is going to be informed based on what you folks need. We're going to actively monitor, what you're using, and we're going to continually augment the collection. But now that you've asked me that question, I'll answer it anyway, Ashley. I'll actually pick 𝗦𝗽𝗲𝗸𝗫. I like it because it's it does a faster way to look at the UI, and it provides structured data out of it. I think it's super important for agentic workflows. So I'm excited about 𝗦𝗽𝗲𝗸𝗫.
All right, that's great. Thank you. And maybe I'll add, there's a couple of models in the catalog right now that are dealing with proteins and different prediction tasks around proteins. You mentioned one, 𝗦𝗽𝗲𝗸𝗫, that's in there. There's another recent release called BioEmu1. And look, my background is in signal processing and machine learning, but it's really cool to have colleagues that actually have deep backgrounds in the health and life sciences. And so hanging around with those colleagues, I've learned about the important role that proteins play in pretty much every biological function, in your bodies and in living things. And so if you think about all the instructions encoded in your DNA, proteins are really the actuators that operationalize those instructions, telling your body how to grow, telling your immune system how to run. And so what I've learned is that actually understanding how proteins operationalize those instructions in your DNA is one of the great scientific challenges of our time in the health and life sciences. And so as you've heard a lot of excitement about the task of structure prediction, right? So you have these sequences in your DNA, and they essentially give rise to these proteins that have really complicated three-dimensional structures. So going from the genetic code to the three-dimensional protein structures has been a task that the computer science community has really taken up in spades over the last few years. And you can go out and play with different models that do that. But it turns out proteins are dynamic. And it's not just the 3D structures that they take, but it's the interactions that they have. It's the way that those structures change over time, and the way that they interact with things like small molecules for drugs, the way that they interact with other proteins in cell systems. And so for BioEmu, that really is about how do you start to get to that more dynamic view of the 3D structures that proteins take? And so BioEmu actually starts to predict more of a distribution of three-dimensional structures. And so this is just an area that, if you want to get real nerdy about health and life science, proteins is a good place to focus, and then that also connects you to some of the, again, the focus of the computer science community in this space and some of the tools that we have available in Foundry Labs. Okay, so with that, we've got about 10 minutes remaining, and be happy to take some questions or even comments or reflections from y'all. Sure, this gentleman here, and I've got my friend here in the front. Oh, is it question first in the back? Okay, sure.
Yeah, sorry. I had a question about 𝗦𝗽𝗲𝗸𝗀 and computer user agents. When I first started to learn programming and scripting, it was in a really prosumer low-code language that Apple developed called AppleScript. And it required anything to be installed on the Apple OS system to have a dictionary of all of the actions it could take. It feels like 𝗦𝗽𝗲𝗀 is really cool in that it can do a visual screenshot and do everything, but it sounds kind of inefficient. Do you foresee some sort of protocol for applications to give a computer user agent a bird's eye view of what the system can do?
Well, first of all, on top, we'll agree with you that 𝗦𝗽𝗲𝗀 is really cool. But as AJ mentioned, feedback in terms of the use patterns and what it might be able to do in the future that it can't is super valuable. So AJ, maybe I'll ask you to take this one.
Yeah, I can take that. That's a great question, and we've been thinking a lot about the progression of this work. So if you have seen Kevin talking about anew, that's actually a completely alternative approach and closer to what you're talking about. So with anew now, we can take any website and actually convert it into an API, an agent that we can call in to get things done. And I think we are gonna have these two parallel ways because basically what 𝗦𝗽𝗲𝗀𝗀 does is it gains access to anything a person has access to. And then we can create this much more efficient way of accessing online content through protocols like anew. The reason we still want to pursue both directions is that we really don't know what the ecosystem is going to play out. For example, if you're a content provider that really benefits from showing ads to people, and now with anew there are not going to be any ads presented, would you create some kind of blockers to prevent anew-like interaction to happen? In that case, 𝗦𝗽𝗲𝗀𝗀-like approach is going to be a really good backup. But we are really thinking, one of the things we do at Microsoft Research is we project into the future. We say, what are the core capabilities needed for these agents to be able to work in the world? And one of them is they need access to content. They need access to web. And we imagine, yes, this is kind of the obvious way. There can be better ways like anew, but there could be other kind of evolving ecosystem plays here that may actually determine what wins at the end. So we are exploring all of that.
I would just want to add, I think from a practical standpoint, I would talk about the fact that you could use both together. Because think about how often you get to a web button and it doesn't take you where you expected it to take you, right? If that dictionary is wrong, 𝗦𝗽𝗲𝗀𝗀𝗀 might be part of the clue of understanding when that dictionary is wrong, that the 𝗦𝗽𝗲𝗀𝗀𝗀𝗀 might be able to rely on the dictionary. If whatever I'm building, I would want to access both and be able to have that conversation about the context of what decisions that computer agent is making.
All right, thanks for the question. That gentleman in the front here.
Thank you. I'm sure you get that question very often, but one thing that I find I struggle a lot when I'm on client sites, I'm a consultant, so I need to be where the clients are, is choosing which framework. And often, you're looking at things, semantic kernel, AutoGen, we're learning about Magentic 1, and I'm sure there's going to be others coming in. So can you help me summarize within the Microsoft frameworks, when should I be considering which?
That's a question we get all the time, and we are solving that confusion problem. Both semantic kernel and AutoGen is going to be part of the agent service in Foundry. And we are taking the best pieces of AutoGen and semantic kernel and bring them together on a single stack so that you will no longer will have confusion about which stack to use.
Yes, we abstract away that detail from you, so we make it fully turnkey for you through agent service.
Yeah, I would say starting with these foundations that you can see are converging, both from what you've seen in the, at Build and the comments we've had here. And so if you're looking to build something that you want to deploy at scale, the first place to turn is to these foundations. I think if you get into a mode of experimentation where we start to run up against the bounds of what we can do today, and you want to start to explore what's next, that's when you can turn to some of the emerging foundations that AJ talked about today, and that we have in places like Foundry Labs to explore.
Just a clarification about your question, right? We are really moving up the stack right now from a research perspective. So the platform layer that makes sure that agents can talk to each other is maturing. That's what the agentic stack currently provides by integrating semantic kernel with AutoGen. And Magentic 1 comes on top of it. It's not the same thing as AutoGen. Magentic 1 is an actual agent team that can do things for you and that actually sits on top of the agentic stack.
Thanks for the question. Next question. Gentleman in the back.
So right now, you could say that identity and access management for humans is terrible, especially across organizations and on the internet. And one could even say that sort of strong authentication and identity management was really ignored in the early days of the internet. Are we repeating a pattern with agentic AI? Because again, right, if you're going back to a group of agents, there needs to be a strong level of trust, and that management of trust is not necessarily going to be under a single domain if you really want it to be, cross-organizational.
Yeah, establishing that trust is going to be so important as we move into the agentic AI era. But Vaidya, I want to give you the first crack at this one.
Yeah, I mean, teeing in on that question, agentic servers will abstract all those enterprise security aspects for you. So we take care of that so that your calls, function calls, and everything is all accounted for. So I would actually suggest to go look into the agent service breakout session to get more details on how we do it. And again, this is an evolving area. So you want to make sure that there are multiple ways these agents are built, right? I mean, there are obviously things that you do by wiring up through the agent service. But what if you bring your own agent? How do you do it? How do agents interact with each other? So suggest you go to the breakout session there and take a look at it. It's a detailed topic.
Can I add something to it as well? So there is the question of entitlement and access. And there is what as humans we expect these agents should do and what they should never do. The top layer is still a very open research question, and we built Magentic UIs to start studying those problems. Just to give you an example, agents now powered with the latest reasoning models can get very, very creative about how they get work done. And because these agents are given a task and say, do it, and they explore many different ways of getting that job done. That's what agents are. So lately, some of the experiments we've been doing with Magentic 1, for example, we have given these agents a task of finding some information that government should be providing online. And the agent goes, and that file is not available there anymore. But it reads that there's actually a government mandate that says that if somebody puts an inquiry to the government has to provide that data to the user, and goes ahead and starts emailing the government about it, right? This is just kind of showing us this very interesting horizon that's emerging with agents powered with reasoning models. They have access to a lot of actions with models like 𝗦𝗽𝗲𝗸𝗫, with APIs and tool usage. And we don't yet understand all that can happen at that frontier, and that's why we are doing the research.
Completely agree. I think with the data privacy aspects, you could control through the agent service, but again, the way the future is evolving through MCP server, you could literally do a cross-cloud interop, right? So how does that data get exchanged? How do you now, these are evolution that is happening, and again, those things again be captured in our Foundry Lab as we innovate. Because ultimately, I think my top of mind, I mean, from this audience and those who are online is, these are foundational innovations, and we want to give early access to this to all of you. We want you to participate and give your feedback, right? Because we are at the time where things are moving so fast. The feedback loop is so important. So.
Yeah, I would like to highlight one piece of work from 𝗦𝗽𝗻𝗀𝗀𝗀's keynote yesterday in terms of red teaming of agents that I think is going to be a fundamental piece of protection.
Oh, absolutely.
Yeah.
Absolutely.
All right. Vaidya, AJ, we'll go ahead and give you the last word there. And let's thank our speakers once more. Thank you all for joining. Enjoy the rest of Build.